building on Hermez with JavaScript SDK.
Hi, everyone. Thank you. I'm going to share my screen in order to perform this workshop. Okay, this workshop will be about interacting with Hermez Network. As you may know, Hermez Network is a layer 2 solution based in ZK rollup. Okay, so in order to interact with this Hermez Network, we built an SDK in JavaScript. And what we're going to do in this workshop is to learn how to set the environment of the SDK, how to create a wallet, how to make a deposit in Hermez Network, and at the very end, how to do a layer 2 transfer, a standard transfer in layer 2. Okay, so I assume here that you have a very basic knowledge about Node.js, about NPM, which is the package manager of Node. So the first thing to note is that we're going to import some standard libraries of Node, which is Path and Ethers. Ethers is a very well-known library used in order to interact with Ethereum. And at the very last, we're going to import our package. You can find our package in NPM. And you just have to install it with npm install Hermez network / Hermez.js. Okay. So first of all, what do we need in order to start this workshop or in order to interact with the Hermez network? Okay. So here, what I'm going to show is the variables that I'm going to use in my workshop. Okay. And probably it will be the variables that in case that you perform some script or you perform some interaction with the network, you will need to set up. So here, this is just an example. I have, obviously, I have my own hidden .environment file. And here, what I'm going to set up is the Ethereum node URL. I will use an Infura one here in this workshop. You need to set up your Ethereum private key. Which token do you want to deposit and transfer afterwards in Hermez network? Regarding the token, you will find there are several tokens available that you can deposit and transfer in layer 2. We will see later all the tokens available when we perform the deposit action. Then here we're going to set up the deposit that we want to insert into the layer 2. And afterwards, how much are we going to transfer in layer 2? Also, you can perform, in this workshop, I will perform 4 different actions, but of course, there are so much actions to perform. I will share a link to a repository in GitHub with several more actions besides the ones that I'm going to present here. And one of them is to perform an exit. And afterwards the exit, you can perform the withdrawal. It's in order to get out of layer 2 and recover your funds in layer 1. Also, when performing a transfer, of course, you need a receiver. And here we are just setting the Ethereum address of the receiver that we want to transfer our funds in layer 2. So let's start with setting the environment. Okay. So when you just download the repository, the Hermez network Hermez.js SDK, there is one setup which is by default, which is the default environment. Okay, and the default environment is set to localhost. So now what we're going to see here is which is the default environment that is set up. I want to run the script, and you can see here that the default environment points to Hermez hard-coded smart contract, withdrawal delay smart contract, which I'm not going into details here, but this is regarding when you perform the withdrawal function. And also the base API URL, which is the coordinator, the batch explorer, which is like the Etherscan. The base API URL is the URL of the coordinator, and the coordinator is the forger of batches on layer 2. Okay, just to do a similarity, the coordinator is for layer 2 as the miner is for layer 1. Okay, the batch explorer will be our own Etherscan. Okay, in order to find transactions, in order to find your account, and so on. So here I want to show you the file that is inside Hermez, okay, which is called environment.js. So here you can find that all the data are already available. So what do you need in order to set the environment? What you need is just only the chain ID. And if you set up the provider, in our case, I will be interacting with Infura in Rinkeby. Okay, with just that variable, I will set up the whole Hermez SDK. Okay, so here we can find all the correct URLs regarding mainnet, Rinkeby, and local of the coordinator, Etherscan. All the contracts are already here because they are already deployed on Rinkeby and mainnet, and so on. Okay, so it's important to notice that just with a single parameter, which is the chain ID, we are going to set up the environment. So here, what I'm going to do is to get the chain ID from my provider. Okay, here I'm just loading my provider with the library of features. Here I'm getting the network information, and from the network information, I'm getting the chain ID. So Hermez.js provides you a single function in order to set up the environment. Okay, that's it. That's all that I need in order to set up the environment. What I'm going to see now is how this. So let's run it. Okay, you can see, you can notice the difference from the previous one. It was localhost and local deployment, and here you already have the smart contracts that are deployed on Rinkeby, and all the URLs regarding the coordinator, the batch explorer, and the Etherscan are pointing to Rinkeby as well. Okay, another important thing, this is just in order to save time for further scripts, is to set the provider. Like the library of Ethers does, you can connect smart contracts, you can connect some signers, but in order to use them, you need to connect a provider in order to sign the transactions and perform interactions with the blockchain. So in this case, we perform the same in Hermez. So we are able to set the provider globally. Okay, you can set the provider in each function if you want, but it's more comfortable for the developer experience in order to set the provider globally in the whole SDK, and every time that you will use a contract interaction, this provider will be already set up. Okay, so here we are just basically setting up the environment with just a single parameter, which is the chain ID, and setting up the provider globally in the SDK. Okay, so let's move forward to the next one, which is the create wallet. Okay, what we're going to do here. What we're going to do is to create the private keys of the baby jab private keys. The baby jab private keys will be used in layer 2 because are the keys necessary in order to sign L2 transactions. And this private key will be generated from your Ethereum private key. And this generation is deterministic. Okay, so you will be always available to create. If you have your Ethereum private key, you will generate your baby jab private keys deterministically. So here, I will just copy paste the previous example, which is load environment files and set up environment and provider. But this time it's more packet in the code with just 4 lines of code. I just set up the environment and the provider. And here also I load the private key of the Ethereum. So what I'm going to do now is to create the wallet. And that's it. How do we create the wallet? Well, what we implement here, there's several ways in order to load your private key. One of them is through directly your private key. Use it a signer, okay? We use this kind of loading to wallet because it's very similar to the one that is used in Ethers. So developers are used to work with this kind of code. And also, it's very important that you can load your wallet in such a way with a private key, but also you can load a wallet with your JSON RPC provider, okay? In that way, the SDK that we provide not just only work in order to do some scripting, but it also works with browsers, okay? In fact, with MetaMask. In fact, this SDK that I'm presenting in this workshop is used in our web app application, exactly the same. But instead of loading a private key, you are loading the provider of the MetaMask, for example. Okay, so we are loading here the signer, okay, and we use a method from Hermez in Hermez wallet section, create wallet Hermez from Ether account, okay, and we are just passing the provider and the sign, okay, and inside that method there is a way to generate the baby jab private key and public key, okay. I'm not going into the details. You can ask me in Discord about the details, about the specific details of Hermez, how to generate these baby jab private keys. But just a single point is that we are just signing a message and then hash it in order to get the baby jab private key, which is basically this, well, 8 lines of code here. Okay. So I'm just going to show which are the values of this account. Okay, I will run the script, create wallet. Perfect. So here you can see that I created the wallet, okay? And I repeat, when I created the wallet, I took the Ethereum private key, I generate the baby jab private key, and of course I also have the public Ethereum key and the baby jab public key. So here, I just want to show you which are the different types of baby jab. Okay, this is the public key, baby jab point in the elliptic curve, X point, Y point. This is the XY point in compressed way. This is the baby jab expressed in hexadecimal string. This is the baby jab expressed in base 64 encoding. Okay, and this finally is the Hermez diagram. If you just play around with our web app and you just play around with the Batch Explorer, you will notice that we use, for user interface, we use the baby jab encoded in base 64. This is very helpful for the user because it helps to differentiate Ethereum addresses and baby jab addresses. One is expressed in hexadecimal string and the other one is expressed in base 64 code. Okay, let's move forward and perform a deposit. Okay, you will notice that I will just, again, copy and paste all the code that I shared previously. And I also load 2 more variables. And I'm just in 6 lines of code. I'm just setting up the environment of the provider and creating a wallet. Okay, so what I'm going to do now, I want to perform a deposit. So the first question is, which token do we want to use? Okay, in order to do that, first I'm going to show you which tokens are available in Hermez network in Rinkeby. Okay, So you just call, there is an API, a public API that you can call and get all the public tokens that you can deposit. And for that purpose, I will show you which tokens are available. So for example, we have, in the first place, we have Ether. The second place, we have Hermez, USDT, DAI, Uni, and Link. Okay, just for clarity, and in order to not show some information again, I'm here in this 2 lines of code. I'm just grabbing the token that we set up in the environment variables. Okay, so I'm just filtering the array, we can say that. So here we have all the token information that we need in order to perform a deposit afterwards of the token that we want to deposit. Okay, so which is the next thing to do when you want to perform a deposit? So of course you will need how much are we going to deposit. So you probably may notice that this how much we already took it from the environment variables. And there is an important thing to mention here, that this is not straightforward because we are not using 256 bits in order to represent a big integer. We are using a custom floating point code encoding, which we call float 40. And this has been done in order to save space when we publish all the data availability in the smart contract. As you may know, ZK Rollups, we must publish all the data in order to rebuild the state tree from zero, from scratch, on chain. Okay, so in order to do that, we need to publish all the data of all the transfers that the user made on chain. And in order to save space, we are using a custom encoding, decoding big integer. Okay. In that case, in the SDK, we wrap all this coding and encoding, and we call it Hermez compressed amount. So at the very end, you just need to insert the big integer into this Hermez compressed amount, and the amount that you will receive is the amount that you will send to the smart contract in order to perform a deposit. Okay, so we have now the token, we have now the amount, so nothing left. So what we're going to do is to perform finally the deposit. Okay, what this action, what it will do? This action, what we'll do is to send a transaction to the smart contract, okay, and the smart contract will handle these transactions, and after a few time, okay, your account will be created in layer 2. Okay, that's it. In order to see that your account is already created in layer 2, we need to wait some time. For the purpose of being faster, I already made this action yesterday, and I also create an account. So the account is already created. But as you can see, it's just only a very smooth interaction with blockchain, because I insist this function here sends a transaction to Ethereum, to the smart contract of Hermez, and creates for you an account. So once your account is created, we are going to perform a transfer, a layer 2 transfer. So in order to do that, I will just copy paste again the code that I used before, but this time, okay, setting the environment provider, setting the wallet, and I'm going to initialize the transaction pool. Okay, I'm not going into the details here, but you can imagine that this transaction pool works as the transaction pool of MetaMask. Okay, so if you perform 2 transfers in a row, the nonce will be handled automatically by this transaction pool. You will send nonce 1 and nonce 2. Okay, like it happens with MetaMask when you perform some transaction. The transaction is in the Ethereum pool. It's pending, but if you perform a second transaction, the second transaction will have a nonce plus 1. So the nonce is not repeated. So in order to perform the transactions in layer 2, we need to initialize the transaction pool, okay? Which is basically to handle nonce properly. Okay, the following lines you will see that are very straightforward because are the same that we use in the deposit section, which is basically set up the token information and set up the amount to transfer. Okay, and here, what I'm going to see, we're going to look at the account that we have just created in the previous step, okay? In order to do that, I'm going to run script. And here, we can see our information regarding the account that we have created in the deposit script, okay? So my account has been created. I have this account index, I have this balance, my baby Jab address, public address is this one, my Ethereum address inside layer 2 is this one. I already performed a transaction yesterday, for example. Okay, and this is the token that my account has. This, for example, is Ether. Okay, so what do we need in order to perform a layer 2 transaction? As in probably all blockchain, the most common fields in order to perform a transaction are just from, to, sender, receiver, amount, and fee, and that's it. That's the only things that we need in order to perform a transaction. Okay, so what we have already, we have the from, which is me, which is this account, and here I'm just grabbing the fee. As it happens with Ethereum, I will ask to the coordinator, like you will ask to Ethereum network, which is the current fee. You will ask the coordinator on layer 2, which is the current fee. So the coordinator will answer you, which is the expected fee, in order that your transaction will be inserted in layer 2. And we are just computing here, which is the fee that I need in order to perform this layer 2 transaction. I'm going to run the script in order, and then you will see which is the fee. For example, this is the fee in Ether that I'm going to pay, that I need to pay in order for my transaction to be inserted. Okay, and there is one more step. Well, there is one thing important to mention, that the protocol that we use in layer 2, the fees are paid in the same amount that you perform the transaction. So if you perform a transaction with Ether, you will pay your fees in Ether. If you perform your transaction in DAI, you will pay the fees in DAI. Okay, that's a different approach rather than Ethereum, for example. But I think it's better because it's allowed to you to pay in whatever currency that you want, whatever token that you want, because you can link transactions and pay transactions in the token that you want. Okay, as I said before, what do we need in order to perform a transfer? We need who is going to perform a transfer, who is going to receive a transfer, the amount, and the fee. So here, this is my account, this is the sender. The receiver, I set it up in the environment variables. The amount, I have just compute the implicit amount in float 40, remember? And the last variable is how much I'm going to pay. Okay, so here, when you send a transaction in Ethereum, you send a transaction to the Ethereum pool. And here in layer 2, it happens exactly the same. So we are going to send the transaction into the coordinator pool. And then the coordinator pool, which gives us a result if this transaction has been correctly inserted into the layer 2 pool of the coordinator. So I'm going to run the script, and this will be the last step. This will be, this script will send to the coordinator the layer 2 transaction. Perfect. So what happened here? It happens that we send the transaction to the coordinator, and the coordinator verifies, of course, if the signature is okay, if you have enough balance, and so on, in order to accept this transaction. If the nonce is correctly signed, if the nonce is the nonce that your account needs in order to perform this transaction, and this transaction has been inserted into the pool, and it will be processed in a few minutes. Okay, but it's important that the coordinator has responds us that the status is okay, and this is the transaction ID. So with this transaction ID, you can go to the batch explorer or just directly to the API of the coordinator and see which is the status, okay, of the transaction. If it's pending, if it's forging, if it's already forged. It's like the status of an Ethereum transaction when it's pending or mined. Okay, that would be all. There's 3 minutes left. If you want to ask anything.
Thanks so much, Carlos. That was great. And you packed in a lot there in just under 30 minutes. There is one question that came in, which is, how is the fee calculated? It seems like it's predefined.
How is the fee calculated? Basically, we are asking to the coordinator, which is the fee that the coordinator needs. Okay, it's like when you're asking to the Ethereum network, which is the fee in order that your transaction will be processed. In this case, the coordinator, as you can see here, okay, we just ask to the coordinator their global state, and inside the global state, there is this recommended fee, okay, in order to perform a transaction. And basically, I'm just grabbing this recommended fee. I'm dividing the recommended fee by the token price of Ethereum in order to know how much Ethereum I need to pay in order to send the layer 2 transaction.
Great. Thanks so much, Carlos. We on time here. That was a great session. And any questions for Carlos, you are more than welcome to drop them in the Sponsor Hermez channel in Discord. And with that, yeah, we'll close out the session. Thanks so much, Carlos.
Thank you very much. And thank you very much for everyone. I will be in Discord in order to answer all your possible questions. Thank you.
Great. Cheers, everyone.
Bye-bye.